Okay, this is lesson 7.1, simplifying rational expressions. A rational expression is an expression that can be written as a fraction. So here's some examples of rational expressions. All these are expressions that can be written as a fraction. Okay, and the one big thing about rational expressions is the denominator cannot equal 0. So the denominator cannot be 0. Alright, so let's look at some problems that that uses rational expressions. Okay, so let me arrange here. Alright, here's a problem. We're asked that, are there any values for x for which each rational expression is undefined? So basically, what this question is asking is, would there be any time where this fraction would be undefined? In other words, is there any time that the denominator would equal 0? Well, the only time when the denominator equals 0 is, what we do is, we take the denominator, x minus 3, and we say, when will the denominator, x minus 3, equal 0? Let's solve for x. And when we move the 3 to the other side, we get x equals 3. So in other words, the value of x that will make the denominator 0, or in other words, this fraction undefined, is 3. Because if I put 3 right there, 3 minus 3 is 0, then I will have x over 0, and that's undefined. So basically that's what the problem is asking. Is there any value of x that will make this undefined? Yes, x equals 3. Following that, let's go ahead and do letter B. Letter B, I have a denominator, 3x squared minus 5x plus 2. We don't care about the top, because the only thing that can make this undefined is the denominator. And the question is, when will the denominator equal 0? So we're going to come here to the side and write down our denominator. And if you remember, this is a quadratic, so what you do 3 times 2 is 6. So then we're going to break down 6. Numbers give me 6, 1 and 6, 2 and 3. What are the sign of the biggest, which one of these give me a 5? Well, both of them gives me 5. So that means, what is the sign of the biggest? Sign of the biggest is negative. So negative 3 plus 2 or minus 2 will give me negative 5. Well, the answer is negative 2. And negative 6 plus 1 or minus 1 will give me negative 5. Well, the answer is negative 1. I'm sorry, positive 1. Because negative 6 plus 1 is negative 5. Final check. When I multiply the signs, I should get the same sign as the last term. So a negative times a negative gives me a positive, so that is good. A negative times a positive gives me a negative, so that means this is out of the picture. That doesn't work. So my numbers are negative 2, negative 3. So we're going to copy the first term. We're going to bring down negative 2x, negative 3y, not 3y, 3x, and we'll bring down the 2. So basically I split up number 5 as negative 2, negative 3. Okay, now let's see if we can group them. So if we group them, what can I factor from the first 2? Well, I can factor out an x. So that means this would be 3x minus 2. And the last 2, what can I factor from both? Well, the only thing I can factor is a 1. So let's put a negative, a 1. So negative 3x divided by negative 1 is 3x. And positive 2 divided by negative 1 is negative 2 equals 0. And now we're going to split up. So this would be 3x minus 2 and x minus 1. Okay, so basically now that means one of these have to be 0. So that means we split this up, right? So this would be x minus 1 equals 0. And how do I get the x alone? I just move the 1 to the other side. So that means one of my answers is going to be x equals 1. And the other one is 3x minus 2 equals 0. Move the 2 to the other side. So you get a 2. I'm going to divide both sides by 3. Sorry, I'm running out of space here. So that means x. Let me redo this because I don't have a lot of space here. So what I'm going to do, I'm going to take this 3x minus 2, set it equal to 0, and I'm going to solve for x. So move the 2 to the other side. Divide both sides by 3. And that means this is x equals 2/3. Okay. So that means, what are the values that will make this denominator 0? The answer is 2/3 and 1. Okay. In other words, if I plug it in number 1 over here and here, when I combine all these, this is going to make this a 0. Okay. All right. So let's move on to the next one. Okay, question is, what value of x will make the denominator 0? And the answer is, there's no value of x on the denominator, so there's no chance that the denominator will ever be a 0. So that means here, there's no value of x that makes this undefined. Okay? Alright. Now we're going to do the next one. So here we have x squared plus 1. So we take the denominator, set equal to 0. And basically, can we factor this? And the answer is no. So basically, there's no value of x that will make this a 0. Okay? Because you're not able to factor here. Okay? So basically you just write no value or no. So you can write no or no value. Okay, very well. So let's go ahead and stop the video and try the next 4 problems to the right of this problems here, and then turn the computer and the video back on and to see the answers. Okay. Welcome back. Here are the answers for the first 2. Basically, I took the denominator, set it equal to 0, solve for x. X equals -6. Okay, the next one, is there any value of x on the denominator? The answer is no. So there's no value for this problem that will make this undefined. The next one, I have x squared minus 6 plus 8. So basically I wrote x squared minus 6 plus 8 equals 0, and I try to factor this, and I was able to factor by writing x minus 2, x minus 4, and x minus 2. Let me show a little bit more here. Basically I did x minus 2 equals 0, and I moved the 2 to the other side. And here I did x minus 4 equals 0, and I moved the 4 to the other side, so x equals 4. Okay? Alright. Here, I moved the x to the 4th plus 5 over here equals 0. And since I cannot factor, that means this is no value. Another way to think of this is, if you move the 5 to the other side, for example, is there any number that raised to the 4th power give you a negative number? And the answer is no, because there's no number that you would put over here that will give you a negative number. Okay? Because any number that I put in here will turn positive. So that's why there's no value. Okay? But basically, you can just look at this and say, can I factor this? The answer is no. So that means there's no value. Okay? Alright. Now we're going to do the other part of lesson 7.1, which deals with simplifying rationals. Okay, simplifying rational means that we're going to try to write the fraction in the lowest terms possible. Okay, so the first thing you need to do when you try to simplify a rational expression is try to factor the numerator, and then try to factor as much as you can on the denominator. So let's look. On the top, there's not nothing really that I can factor, so I'm just going to copy it. But on the bottom, what can I factor from 6 and 3? Well, I can factor out of 3. Can I also factor out a y? Yes. Well, since this one has a 4 and this one has a 3, I picked the smallest number, which is 3. So that means I can factor 3y to the third. So 6y to the fourth divided by 3y to the third is 2y. And negative 3y cubed divided by 3y cubed is negative 1. And now the 3 goes away. Because I have a y cubed and y squared on top, okay, the biggest exponent is on the bottom. That means the y stays in the bottom. And 3 minus 2 is a 1. I don't have to write the 1. But if you do, that's okay. And I have 2y minus 1. Now, on the top, because the y stayed on the bottom, there's nothing on the top, so I'm just going to put a 1. Okay, because you cannot leave it any blank over there. Okay. So basically the 3 cancels. Y cubed minus y squared, the y stays on the bottom, and then 2y minus 1 stays on the bottom. Okay, so I have simplified this rational expression. Okay, let's look on the next one. The next one, I have x plus 2 squared. Well, I can rewrite this as x plus 2 times x plus 2. On the bottom, I have x to the fourth minus 16. So what I'm going to do is I'm going to remember that property or formula that says a squared minus b squared equals a plus b, a minus b. So basically in the back of my mind, I'm looking at this and I say, I can apply this rule. Okay, because this is a perfect square and so is this. So what is the square root of x to the fourth? It would be x squared plus 4, because the square root of 16 is 4. And then this would be x squared minus 4. Now, whenever I see a square or anything that is even and a minus, I'm automatically thinking of this guy. Okay? So basically this guy here becomes x plus 2. Well, it doesn't become. I'm going to copy again. Okay. This guy, there's nothing I can do, so I'm going to copy again. But this guy here is the one that I can apply this rule again, because I'm going to take the first one and take the square root of it. So this would be x. Square root of 4 is 2. So it would be x plus 2, x minus 2. Alright, so I have factored the top, I have factored the bottom as much as I could, and now it's time to cancel. So if I see it here, x plus 2 and x plus 2 cancels. I cannot cancel these two because this one is a minus and this one is a plus. So basically I'm left with x plus 2 on top, and on the bottom I'm left with x squared plus 4 times x minus 2. So that's my simple form for this. Okay, let's continue on. Last problem here. I have 5x minus 5 and x cubed minus x squared. So basically I ask myself, what can I factor from the top? From the top I can factor out of 5, so it would be x minus 1. On the bottom, what can I factor from both? I can factor out of x squared. So x cubed divided by x squared is x, and x squared divided by x squared is negative 1. So that means x minus 1 cancels from both top and bottom, and I'm left with 5x squared. Okay, so why don't you stop the video and try the problems on the right at this time. There's 3 problems, A, B, C on the right, and go ahead and try those, okay? And then you can restart the video to see what happened. Okay, welcome back. Here are the answers for the problems on the right. It's supposed to say practice problems. Okay. Basically, if you can see on this one, I factor out of 5z to the 4th from the bottom. 10z to the 5th divided by 5z 4th is 2z. Negative 5z 4th divided by 5z 4th is negative 1. And basically, I can cancel 5z to the 4th, 5z to the 4th, so that means I'm left with 1 on top, and I have 2z minus 1. When you have your final answer, you can either put parentheses, or you can leave it the way it is like this. So either way is fine. I'm just going to leave it like that. Okay. Okay, on the bottom one, I notice again that I can apply that special rule, a squared minus b squared equals a plus b and a minus b. And as you can see, then this becomes x plus 3, x minus 3. And on the bottom, I have a 6 at the end, so I make a little list of numbers that give me 6. 1 and 6 give me 6, 2 and 3. Then I check the sign. Well, I check for something that gives me a 1, and the only one that gives me a 1 is the 3 and 2. And because this is a positive, 3 has to be a positive. So positive 3 minus 2 gives me a positive 1. And a positive times a negative gives me a negative. So I know that I'm on the right track. So I then put these numbers over here. Okay. And then, once I have that, let's go ahead and cancel the numbers. And I have x minus 3, x minus 2. Okay. Alright, next problem. Basically, I factor out x to the 5th. I got x minus 1. And here I factor out a 6. Cancel the x minus 1, got x to the 5th over 6. Okay, so let's go ahead and turn the page now and look at some more problems where we're going to simplify the rational expression. Okay, here we have problem letter D. Okay, basically you're going to take the last term here. I'm going to write here on the side 7. And what numbers give me 7? Well, 1 and 7, and that's it. So would 7 give me an 8? You bet. So 7 has to be positive. And the 1 would have also to be positive, so 7 plus 1 gives you an 8. And final check, a positive times a positive does give you a positive. So this would be x plus 1, x plus 7. Okay, next one is a 5. What numbers give me a 5? It would be 1 and 5, and that's it. Would 1 and 5 give me a 4? You bet. Because this is a negative, I put a negative on the biggest, and negative 5 plus 1 gives me a 4, negative 4. And negative times a positive gives me a negative. Alright, very well. So that means that works. So we're going to put over here x plus 1, x minus 5, and we're going to go ahead and cancel. So that means my final answer is x plus 7 over x minus 5, and that's my answer. Okay, remember you can put the parentheses or you can leave out the parentheses. Either way is fine. Okay, letter E. Letter E, we usually like to have the x in the front, so this is one is good. But here I see y plus x, so let's put them in order. Okay, so we're just going to switch them around. So this would be x plus y on top. No change there. But on the bottom, I'm going to change them places, and what I see is I have x plus y on top, x plus y on the bottom, so that means this binomial cancels with this binomial, and when they cancel, I'm left with a 1. Okay? Alright, let's do the next one. Similar thing is happening here. This is x minus 3y, and this one is y minus 2x. So what I'm going to do is I'm going to switch these guys around. So that means the x on the front. Okay, so this would be x minus 3y, and then I would have negative 2x plus 6y. Please notice that the negative went with the 2x. Okay, all I'm doing is moving this negative 2x in front of this positive 6y. Okay, now that I have done that, alright, I ask, what can I factor from these guys? Well, on the top, there's nothing I can factor, so I'm just going to write the same. But on the bottom, I notice I can factor out a negative 2. And when I factor negative 2, negative 2x divided by negative 2 is x. And 6y divided by negative 2 is negative 3y. And would you look at that? I have x minus 3 on top and x minus 3 on the bottom, so that means these two binomials cancel. And I'm left with 1 over negative 2. So your final answer is just negative 1 over 2. We usually put the negative right in the front because a positive divided by a negative is a negative. Okay, and that's our answer for this problem. Okay, now we're going to do letter F. Basically on letter F, I see that the x is not in the front, so what I'm going to do, I'm going to switch them around. So that's going to give me negative x squared plus 4. Okay, now I don't like to have that negative in front, so what I'm going to do is I'm going to factor out that negative. Okay, and basically that's going to give me negative x squared minus 4. So basically I switch these two around, got negative x squared plus 4. I don't like this negative here, so I factor out the negative, so negative x squared divided by negative is x squared. Positive 4 divided by negative is negative 4. And I notice that this here, I can apply that property that says a squared minus b squared equals a plus b, a minus b. So that's basically what I'm going to do. So I'm going to write the negative that is outside, and I'm going to open two sets of parentheses, and I'm going to write x plus 2, because the square root of 4 is 2, and x minus 2. Alright, now for this guy here on the bottom, I'm going to come here to the side and multiply 3 times 2, which is 6, and break down number 6, which is 1 and 6, 2 and 3. And I'm looking for a number 5. So both of them gives me 5, so it's going to depend on the sign now. So sign of the biggest is negative. So that means to give me a negative 5, this would have to be a positive. And here this would have to be a negative. But because I want a negative here, a negative times a negative gives me a positive, so that I know that this doesn't work. A negative times a positive gives me a negative, so this one works. So I'm going to come over here and break this down. So it'll be 3x squared minus, plus 1x minus 6x minus 2. So basically, brought this guy down, broke this negative 5 as positive 1x minus 6x, and brought down the negative 2. Now I'm going to factor by grouping. So this would be x. This would be 3x plus 1. One number goes into 6 and 2. Well, 2. So this becomes 3x plus 1. So basically, what repeats? The 3x plus 1 repeats. And what's left over? X minus 2. So basically I factor this into this, so I'm going to write it over here. And once I wrote that, I can decide what I'm going to cancel. And I notice that I can cancel the x minus 2. So that means my final answer is negative x plus 2 over 3x plus 1. And that will be my answer. Okay, let's go ahead and go on to the next problem. First thing I see is x cubed, and first thing I think of is that property that says a cubed plus b cubed equals a plus b, a squared minus ab plus b squared. So, with that in mind, what is the cube root of x? Well, x. What is the cube root of 27? 3. So now I just apply the rule. I take the first one and I square it, and then put a minus. The first times the second, so the first times the second is 3x, plus the second one squared, so the second one is 3. 3 squared is 9. And then I copy the bottom because I cannot factor anything on the bottom. Now, with that, what can I cancel? The x plus 3. So that means I'm left with x squared minus 3x plus 9. And that will be my answer. Because, as you remember, whenever you do this special property, this guy over here, you won't be able to factor. But if you forget about that, you can always try, break down 9. 1 and 9, 3 and 3. And as you can see, there's nothing here that will give me a 3 in the middle. So I know that's all I can do. So I'll leave my answer like that. Okay? Let's go on to the last problem. First thing I see is that I can factor out a 3 from the binomial on top. So this would be x squared plus 2. And on the bottom, let's try some grouping. So what can I factor from the first two? I can factor out an x squared. So that will give me x minus 3. And on the second one, I can factor out positive 2. So that will give me x minus 3 as well. Okay, now what repeats? X minus 3. And what's left over? X squared plus 2. Then basically I come over here and I write that down. And who can I cancel? The x squared plus 2. So my final answer is 3. X minus 3. Okay, so that's my answer for this problem. Okay, at this time, go ahead and stop the video and try the problems on the right side of the paper, and then restart the video when you're ready to check your answers. Okay, welcome back. Here are the answers for the problems on the right side of the paper. Okay, as you can see, I look at the last digit here and I broke down the numbers to give me the different factors, and I'm looking for the number that gives me a 5. So it'll be 1 and 4. Check the signs, positive and positive give me a positive, so that means I can break this guy down as x plus 1 times x plus 4. Did the same thing on the bottom, now with number 8. 4 minus 2 gives me the positive 2, and a positive times a negative gives me a negative, so I can break this guy down into 2 factors. And these guys cancel. On letter E, I factor out x squared, and from both of them on top, and I got x plus 9. I wrote 81 over here, broke it down, and I noticed that 9 and 9 will give me the 18. Signs are positive. Now I can cancel the x plus 9. Next one. I want to make ahead and switch these two guys around. Negative x come to the front, 4 went to the back. I don't like to have the negative in the front, so what do? I factor out a negative 1. Okay, you can either leave the 1 there or you can leave it alone, invisible. But the important thing is the negative, and by factoring out the negative, I have x minus 4 on top. Okay, on the bottom I factored out a 2, so I got 2x minus 4. X minus 4 cancels. I'm left with negative 1 over 2. Next one. Next one is a little more complex. It's not really complex, it's just more work to be done. Basically, what we did is I took this guy over here and I did the factoring. Basically 5 times 6 gives you 30, and I'm looking for a number that gives me 13. So there was 2 options, but I picked this one because a positive and a positive give me a positive. So that means I broke down as 3x plus 10x, did the grouping, and I got that. Then I did the same thing for the next trinomial here on the denominator, and I did the calculations over here on the side, and I figured out that 12 and negative 5 would be the number that gave me a 7. So broke that down, did the grouping, and that's my factorization. So I did all that work on the side. Okay, then what I did is, so basically I found out that this guy here factors into this, so I wrote it right there. And I noticed that this guy factor into that, so I wrote it underneath as the denominator. Now that I have both trinomials factored there, I can cancel, and my answer is that. Okay, remember, you can always stop the video to look closely what I did and replay it back to see what things you didn't quite understand. Okay, and so here we go to the next problem, letter G. So I basically copied this over here on the top, and I did the factorization by grouping. Here are my calculations. So basically I changed this guy into this. This guy over here, I did my factorization by grouping here. And please notice that here I was able to factor out a z squared and here a -1. And when I did the grouping, or like what repeats over here, the 2z minus 3, and what's left over, z squared minus 1. And I notice here that I can apply that property that says a squared minus b squared, right, equals a plus b times a minus b. So basically I can break this guy down as z plus 1, z minus 1. Okay, so basically here I'm using that property that a squared minus b squared equals a plus b times a minus b. So you always have to be on the lookout for those properties to pop up sometimes when you work in the problem. So here I see that it popped out, so I factored. So now that basically I changed this into this, I brought it here, and now I see who can cancel. Z plus 1 can cancel, 2z minus 3 can cancel, so my final answer is 1 over z minus 1. And the last problem, letter H. Again, this here, whenever you see 4 like this, you need to ask yourself, can I factor by grouping? And that's exactly what happened here. You can factor 2x from the first 2 and a -3 from the last 2, and basically you get y plus 1 there. So you get y plus 1 times 2x minus 3. Same thing happened on the bottom. You can factor out 2x from the first 2 and a -3 from the last, and you get these. And basically once you write them like this, you can cancel the 2x minus 3, and your final answer is y plus 1 over y plus 2. So this concludes the lesson for chapter 7.1, and now you can do the assignment problems. Okay, so please stop the video, and thank you very much for your time, and have a great day.